Hello, future engineers, subscribers, viewers, and students. Here is a video about uh, distributed forces, or in particular about pressure. And this problem this problem was given as a quiz problem in statics. And I presented two solutions here. One is by statics alone, and the other one is by still statics with reinforcement of the concept in hydraulics and fluid. So here is the solution. Consider the quarter circular gate shown that is 2.4 meters wide into the screen. So perpendicular to the screen, the gate is 2.4. So that's 2.4. That's the gate. So compute the force F needed to open it. Neglect the weight of the gate. So the weight of the gate is neglected. So this force F will be computed based on these forces. We have pressure force here, and at the bottom it is trapezoidal in distribution or variation, and we will divide this into two triangles. This is the division, that's the smaller triangle pressure diagram, and this is the other one. So the intensity of pressure at this level of A is specific weight of water, which is 9.81, and the depth is 2 meters. So that's why we have 19.62 kilopascals as the pressure at the top point at A of the gate. While at the bottom, it is 9.81 times 2, quantity 2 plus 1.8, so 3.8, and it is 37.278 kilopascals. These forces is equal to the volume of this pressure diagram. So for F1, it is 1/2 of 19.62 times height 1.8, which is the radius of this gate. That's why this must also be 1.8, and that is also 1.8 meters, times width perpendicular to the board, which is 2.4 meters. So it is 42.379 kilonewtons. For F2, it is the volume of this triangular pressure diagram, 1/2 of 32.278 times 1.8 times perpendicular to the screen, again 2.4. So it is 80.52 kilonewtons. Now for weight 1, this is a quarter circular arc. Therefore, the volume is area of the quarter circle times width to the perpendicular to the board, which is again 2.4. So specific weight is weight density of water times volume. So it is 9.81 kilonewtons per cubic meter. The volume is area of this quarter circle times 2.4. Area of quarter circle, pi times 1.8 square over 4. Then width into the screen, 2.4. So weight 1 is 59.912 kilonewtons. Then for weight 2, the density is 9.81, and the volume is the volume of this rectangular parallelepiped with dimensions 1.2, 1.8 meters times 2 meters, then times 2.4. So 84.758 kilonewtons. The line of action of weight 1 is, I already derived this for centroid of quarter semicircle and quarter circle, remember by Pappus propositions, second Pappus proposition. So this is 4r over 3 pi, 4 times radius 1.8 divided by 3 pi, and that is 0.7639 meters. Therefore, the line of action of weight 1 from hinge A is equal to 1.8 meters minus 0.7639. So you have here 1.0361 meters. For weight 2, it's simple as 1.8 divided by 2, so zero point 0.9. So we are now ready to solve for F. Summation moments about A equals 0. So F times 1.8 equals F1 times, by the way, F1, the distance from the top is zero point 0.6 meter, one third of 1.8, while the distance of F2 from the top is two-thirds of 1.8, so 1.2 meters. So let's go back to summation of moments about A equals 0. So we have clockwise moment equals counterclockwise moments. All these forces F1, F2, weight 1, weight 2 are counterclockwise about A. Only F times 1.8 is clockwise. So F times 1.8 equals F1 times zero point 0.6 plus F2 uh, 80.52 times 1.2 F2 times 1.2 plus weight 1 59.912 times moment arm 1.0361 then plus weight 2 84.758 times zero point 0.9. So solving for F is 144.7 kilonewtons. The alternate solution is based from fluid mechanics principles and of course statics. The resultant of these loads is rightward and downward. These are here. And by principle, this resultant passes through the center of this quarter circular gate. And this is the center of the quarter circular gate. And by principle of transmissibility of a force, we can move R through that center of the quarter circular gate and resolve it into two components, Rx and Ry. Where Rx, if there's a need to compute it, it is just F1 plus F2, so 42.379 plus 80.52, so that's 122.899 kilonewtons. Then Ry is summation of weights, weight 1 plus weight 2. So if we sum up moments about A, considering this resultant and the components, then clockwise moment F times 1.8 is equal to counterclockwise moment, which is the moment due to Ry times 1.8, canceling out 1.8, so that means F equals Ry. Rx passes through A, so it is not involved in this moment equation. So we have shown that F is just Ry, and Ry equals weight 1, which is 59.912 plus weight 2, which is 84.758. So that's why F is 144.7 kilonewtons. So that's it for this video.